Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
All right. Welcome back to Happy Path Podcast.
Happy Path Programming Podcast?
Yes, Happy Path Programming Podcast.
The podcast.
That's true. Yes. And we, one of the things that's I want to mention is the Winter Tech Forum here in Crested Butte, Colorado is the end of February, beginning of March that week.
Okay.
And I'm still tweaking the website a little bit, but I should have
WinterTechForum.com.
WinterTechForum.com. That's right.
Okay.
And so it looks like we'll get some good turnout this year and finally have a good time.
Nice to be back.
Yeah, we'll be doing all the good things, the yurt dinner and the progressive dinner and the
lightning talks, hack day, and
which I'm thinking we might have in the movie theater. The lightning talks.
That'd be fun.
Yeah,
that'd be really fun.
Yeah, I'm thinking we might do it there. So anyway, check it out, and hopefully people can come.
Yeah. Great.
So this week we have Benjy Weinberger, who is actually, tell me, because we sort of arranged this in a flurry at the last minute. Tell me what your
who are you? What do you do?
Yeah, pretty much. Yes, tell us who you are and what you do.
Hi, my name's Benjy. I am a software developer and have been one for over 25 years now. So, I've been through several ups and downs of our crazy industry.
Starting with what was the first professional language?
Oh, I started in C++.
Okay.
Back when I think that was kind of all there was. Java was just starting out. So my first job out of university was 1997. Java wasn't quite in a lot of industrial use at the time, and so it was all C++. Plus, I was working at Checkpoint on firewalls and network security, and so obviously that was an obvious language choice. So I cut my teeth on C++ pretty early, and it's all been downhill from there.
Or uphill, depending on which way you're looking.
Good. Yeah. So I've had the good fortune to work at some really cool companies, including Google for many years.
Nice.
At Twitter, at Foursquare, and now I am the co-founder of Toolchain, which is a company in the build systems space.
Nice.
And I'm one of the creators and maintainers of Pants, which is an open source build system with a focus on ease of use, on ease of adoption, and has a strong focus on how companies that are not FANGs use code in the real world. So things like focusing on Python, because that's an incredibly popular language for various use cases, and focus on that kind of thing.
Pants. Now, I mean, the thing that drew me to it, because I've been fooling around with it for the last few weeks, is the Python use. But it also supports, I know you're working on support for some things and you have support for other things. And it's like, it does support Java now. Is that right?
Supports.
And Scala.
Correct.
And you're working on Kotlin.
Now, Kotlin is also fully supported now.
Okay. Nice. Okay.
Once you support two JVM languages, adding a third is actually surprisingly straightforward.
Okay.
Nice.
Okay.
Give us the history on Pants. I get to be the one who knows nothing in this episode. So this is great.
Yeah.
I have obviously heard of Pants, but have never used it and really know nothing about it. So start us at the beginning.
Sure. So what we call Pants today is the third of its name. There were multiple iterations of this project all under the same banner, and it started out about 12 years ago at Twitter, where John Sirois, who is now my co-founder at Toolchain, and I were futzing around with this problem. John had already begun hacking on it. Part of it was the observation that I think is not unusual, that I'd worked at some companies before I went to Google, and had this experience of the tooling just not being very good and not really understanding that better things were possible, because you accept, especially when you're junior, as I was, you accept what's given to you. So, make files that are clunky and slow and hard to work with, and builds that take a really long time. And you just sort of accept it. It's sort of, there's almost a weird, bizarre sense of pride around it. Like, this is what puts hair on your chest. Like, this is what makes you a real developer, is like climbing up the mountain of code with nothing but a janky makefile. And you accept it. And then I went to Google, and my eyes were opened by not so much the tooling, that most of which was not in place. When I joined Google, they were still using a makefile, but the attitude. That was opened my eyes to, no, developers are this is a first class use case, and we will invest in coming up with best practices to make developers more productive and develop the tools to support and enforce those best practices. And that was not an attitude I had previously encountered. The tools, that attitude led to tools.
Google, like, really set a high bar for what some people call today developer productivity engineering. Like, actually, so there's actually a term for it now. I think the Gradle folks have been pushing that, but there's actually a term for this, like, focus and having a team that is focused on making all of the engineers more productive, which I think is awesome.
Rather than just, it's like, it's something you have to do. It's a hurdle you have to get over. It's stuff you have to put up with in order to, but it doesn't encourage really, fine tuning. It encourages just enough, but not really utilizing the tool to make your life easier.
What's wild is that this seems like an area that is so easily measurable, where you can show that we invested this much time and we then saved this much time. But for some reason, most companies don't do it. Like, it seems like the most obvious place to optimize, and yet most people don't do it.
And what's maddening is that many of those companies are trying to get other business functions to do that. If they're making software that automates your sales pipeline or your HR function, they are saying to every other business function, buy our product because of these metrics. And yet they're not somehow not really applying that to their own discipline. I mean, the sort of truism of the cobbler's children going barefoot is really, there's something to that. So after I left Google and went to Twitter, it was like going back in a time machine 10 years and noticing, now we're back to nobody really cares about this area. There is no focus on developer productivity. Everybody's just doing whatever.
So, and going back real quick to Google,
were
you there when they were doing Blaze and iLark and all that? So you were seeing some of the evolution and investment into build tools in particular at Google.
Correct. That was, when I started there was a makefile, and there was I was there, at the point where the makefile itself took sort of 5 to 10 minutes just to parse the makefile. It was a 200,000 line makefile. And there were all these rumors of someone's working on something that's going to be way better. And then it became what is Blaze today. I mean, there were obviously many evolutions of it, but so I lived through that transition, and that really drove home to me, my God, like, it does not have to be this way. If you treat your engineering like a business function that deserves the best tools, you either buy them or build them.
So you got to Twitter and you're like, I just stepped back into the dark ages.
What is going on here? It's not Twitter's fault. It's just the industry had not moved ahead the way that some of the, Google and maybe a couple other giant fangs had done. And so John had already started hacking on, this was before Bazel, which is the sort of open source variant of Blaze, existed. And John had also worked at Google, had the exact same observation I did, and decided to scratch our own itch in this way. And so I joined with him, and we started working on this thing. It was focused on Scala at the time, and this was there were a couple of iterations of this internally at Twitter. The name Pants comes from the very, very first iteration of this that John put together over a hack week, which was it was for Scala builds, and it generated ant.xml files using Python. So it was Python ants, hence Pants. And the name stuck around, even though the thing it is an acronym of did not stick around for very long at all.
So So in that initial version, you would write some Python, and then that would generate XML to then build Scala.
It
I
was
did the very
basically a
same
Python
thing for a
DSL.
book project.
Wow.
Yeah.
Now, was the Python DSL part of that motivated by Skylark, or was that kind of separate
No,
divisions?
that
Interesting.
was Scala was not really a thing yet, as far as I recall. No, it was more just having a way to describe your builds that was succinct and well understood and wasn't XML, because that was sort of the tail end of the XML days.
Yeah.
I remember when XML was just going to be the solution to everything.
Yep.
Oh my gosh.
Oh, I remember that. I remember the sort of going to Java 1 conference around the year 2000, and everything was like, you don't have to write Java code, you can program in XML. And I was thinking, that sounds worse. That sounds like, I quite like Java and I really don't want to code in XML. But like the whole idea of like, you can program declaratively. I'm like, no, that sounds horrible.
Xdoclet. Oh man. Yep. And Jelly script and
yeah.
Wow.
So
rough times.
But you couldn't deny XML, or else you would
don't speak negatively against XML.
Oh no. I mean, but that was the heyday. This was like before the .com collapse, when if you knew anything at all about XML, you were sort of guaranteed to get attention. And yeah,
exactly.
So
okay, so Pan's kind of V1 was Python.
It was basically that. V0 even. We quickly moved away from that. And then the evolution of that, it was really focused on Scala. And after my time at Twitter, I went to work at Foursquare. And they had a very similar, big Scala code base. The builds were taking a really long time. Laptops were running out of RAM because Scala is, a fascinating language, but also a beast.
Yeah.
And I knew about this internal solution at Twitter, and I talked to John about getting Twitter to open source it so that we could collaborate on it and use it at Foursquare. And so that was the first open source version of Pants V1. Maybe that sort of Python ant thing was maybe V0. That was very focused on Scala, and it wasn't really open sourced in any meaningful way other than as a mechanism so that Twitter and Foursquare could both use it and collaborate on it. And a few other companies jumped in on this, but it really wasn't big or intended to be. Where I think what Pants is today is Pants V2, which is massively different from everything that came before it. Really, the only thing that survived is the name. And the differences, and it was very much informed by real world experiences, both of using Bazel, of using Pants V1, of how hard both of those systems were to adopt. And so Pants V2 really was a massive departure. I would say it is really informed by, not by how Twitter or Foursquare or Google or Facebook do engineering, but how the thousands and thousands of other teams do engineering. And
so one of the things that I'm curious about is it sounds like maybe one of the core reasons for Pants or motivators is really about making engineers more productive. Is that accurate? That's part of the why that drove Pants?
100%. I mean, more productive and also selfishly happier. So my manager cares about my productivity. I care about my happiness. And those are in a good environment, those are related.
And did you spend much time studying Gradle?
Not a ton. We looked at, so roughly in my mind, Gradle, SBT, Ant, and Maven are somewhat similar idiomatically, even though they're obviously different systems and they each have different strengths and weaknesses. I'm no expert at Gradle. We realized that that very JVM-centric top-down idiom that those systems kind of impose was not what we were looking for. We wanted something more similar to Pants V1 or Bazel or Buck, where the system understands your dependencies at an extremely fine-grained level, ideally at the file level.
Yeah.
And
versus the kind of class path orientation.
Exactly.
The JVM are always oriented around what is the class path, and that's kind of the core model for that.
Exactly. We wanted to be able to have a sort of the general idiom in many of those other systems is if you have multiple projects, they each have their own class hierarchy, and they get composed together, as you say, at the class path level. And we wanted something very fine grained where you could have a single package tree in whatever language, and the system knows how to slice and dice that for you.
Yeah.
But what we didn't want was to impose, like, the downside of these systems, including Pants v1 and including Bazel and the rest of them, is the maintenance of the so-called build files that contain all that information is very laborious and error prone. And we wanted, one thing we heard loud and clear from all the teams of various sizes that we were talking to is, we do not want that. That is a burden you can impose if you're Google, and you can say, well, this is how we work, and it is part of your job to maintain build files. You're a captive audience, and the adoption only has to happen once. But we were trying to build a system that we've adopted, thousands of times. So we knew that making it laborious was a non-starter. And so that's where we leaned in on static analysis, to what we call dependency inference, to learn about the structure and dependencies of your code from looking at your code instead of from looking at manually written metadata. And that, I would say, is the single biggest difference.
Okay, I want to dive into that, but to take a tangent real quick. So making developers more productive is one of the motivators, but then there's another motivator, which is kind of making the build approachable to everyone on a team, versus, I think, Gradle is
a specialist.
Exactly. Gradle is more focused on a build specialist.
Mm-hmm.
There's somebody who is the build engineer, and they are, if you need a build change, you got to go to them because they're the only ones that understand it. Whereas for Pants, it was, no, let's make it so that everyone can be a build engineer.
For all my Gradle files, James has been my build engineer.
And
and no, oh God, no, we don't. We do not understand Gradle.
Yeah, we'd like that to be, I mean, sometimes your builds are complicated because your code base is complicated. We don't want to add more complexity from the build system. We want the build system to streamline as best it can, because there are really two kinds. I mean, when your podcast a few weeks ago, and you talked to Josh Swereth, like, hitting the nail on the head. There's like there's two audiences here. There's the people who absolutely do not care, and just the tool is a necessary evil to manage things, but I really don't want to know how it works, and every time I have to dive into its documentation, that's a failure. Versus the people who actually not only need to, but want to know how everything works. And so as long as your team has at least one or two of the latter, you're in good shape.
Yeah, but Pants took the other approach, which is, let's make it so that everyone can be that build engineer, essentially.
We'd like to make it, I mean, it's a work in progress, I would say. It is still, there are complexities that I would prefer were not there. Part of that is just the legacy of existing use cases and existing configuration, and there's a lot of sort of pre-existing idioms and assumptions that we are slowly working our way out of. So we are getting closer and closer to the day where the tool essentially adopts itself, and we're much closer, I think, than we were, and much closer than any other tool is out there. There's a lot of automation around that, as I said, a lot of static analysis. The tool, one thing that was very important, that it goes to that point, is it was very important for the tool to not require you to refactor or change your code itself. So I believe, I could be wrong about this, this is one of the few, if only, tools that will happily handle evil things like dependency cycles, which are generally not healthy, and you'd rather not have them. You'd rather not have spaghetti dependencies, like giant hairballs of dependencies wrapping around your entire code base.
Yeah.
But we handle that if you have it, because we know that's a real world thing, and we do not want adopting Pants to begin with a refactoring project.
Right.
So there's a strong sense of, like, let's meet developers where they are, that provide tooling to help them refactor their code base if they choose, but do not require it as a precondition to using anything.
Yeah.
So one of the things that I noticed is that the design of Pants seems to have a very functional flavor to it. It seems like you're working with immutability, you're caching like test results so that you don't repeat them and things like that. It seems like you've been influenced pretty strongly by the functional mindset.
Oh, absolutely. I think the engine, the Pants is kind of, there are two main layers to the technology. There's the execution engine, which is written in Rust for performance reasons, because it is orchestrating, even in a medium-sized build, it might be orchestrating many thousands of units of work. And then there are the APIs that you actually write the specific rule logic with. How do I compile this Scala file or whatever? Those are written in Python, because most of what they do is set up inputs and outputs and then invoke processes. So they are not typically as performance sensitive, but the engine is. So we had to come up with an API that where, and this took some doing, and there was a lot of clever work by people who aren't me, and then some dumb work by people who are me. And we had to come up with an API that was relatively, it was Python based. Python is extremely familiar to many, many people, where we wanted, and this is one of the lessons we learned from Pants v1, was an important feature of any build system, Pants in particular, is we want concurrency and caching and invalidation to just fall out of the API. We do not want you to have to think about them when you write custom build logic. That is very important, because those things are really hard to reason about. And the functional paradigm lets you do that. Like the fact that you can say, okay, this is a pure function that can neither rely on nor cause side effects, because we run all processes in a sandbox environment. It can only act on its inputs. However, so therefore we can fingerprint those inputs, and we know that is a consistent cache key. Because of those inputs, and we can chain those inputs and outputs together because we know there are no side effects. And so we can create this big workflow graph on the fly.
You know exactly what parts get invalidated when certain inputs change.
Exactly. It also means we can apply concurrency in a
how to split the graph
principled way, because we can see just through graph analysis that these two units of work don't depend on each other, so they can run concurrently. The relying on immutable inputs and on pure functions is what allows the whole thing to work. But we did not require you to learn a relatively obscure functional language. It's Python.
Yeah, nice. And it seems like this is really driven by one of your core motivators, which is to make developers more productive. Because, of course, when you run a build, you don't want to have to redo work that's already been done, if the inputs haven't changed. And that's just a way to make my build run faster.
Exactly.
And, good caching, good invalidation, all that kind of stuff is critical.
It's super necessary. Otherwise, you have to apply those things piecemeal in specific cases, and that is hard to do and hard to get right. And I think we have never had a cache invalidation. We have never had a cache bug where something was cached when it shouldn't. Sometimes things are not cached when they could be. That is a performance issue, and we might tweak the cache key in that case. But it is far better in this world to have a performance problem than a correctness problem.
Yeah. I also really like the way that you chose Python as the top level implementation language, because in Gradle they used originally Groovy, and then on top of that they created their own DSL, and you had to learn all that, and you had to learn the you have to understand the life cycle, or else you'll make just really obvious mistakes, and there are just so many pitfalls.
Yeah. We wanted it to be relatively intuitive Python. We wanted to use words and not symbols. So I think in your conversation about SBT, the DSL was mentioned, and I used SBT back in the day, and it's a very powerful and clever system. And in Pants v1, we actually used a library, the Zinc, which was the incremental compiler out of SBT in library form. But the one thing that really got us was the symbolic DSL, the sort of sideways Christmas trees, where tilde equals angle bracket means one thing, but equals angle bracket means another thing. And I was like, my brain just doesn't work that way. My brain can only consume words.
Yep, we were just last night. Yeah, the being able to create your own operators was a interesting experiment in Scala that is generally considered to be a discovery that we shouldn't do that.
Yeah.
Yeah.
One thing
since you listened to our episode with Josh, you heard the discussion around build DSLs and should they be declarative or programmatic? And it sounds like your builds, because they use Python, are more imperative style, but you have maybe constrained them to be able to have the pure functional kind of things that you need around the build DSL or something. Is that? Tell me
I
more
would
about
say
that.
the DSL, which are build files, was pretty inspired by Blaze / Bazel. So it is not it is full Python. There are it's a little more powerful, and for example, there is a macro. You can write macros that are basically almost arbitrary Python to cut down on boilerplate in your build files even more.
Okay.
But I would say it is still declarative in that you define targets that are just describe what your code is, because there are so many different actions you can perform on them. What we did was, though, Pants has this concept of goals.
Okay.
So the thing you run on the command line is a goal. So you run pants test or pants lint or pants package. These are all those verbs are the verbs in the system are called goals. We wanted there to be a very rich set of goals, and in fact, you can add custom ones as well as part of the plugin API. And the reason is that those goals encapsulate a lot of understanding. There are a lot of semantics there that the system can profitably use. So, for example, when you run formatters that modify your source code, you have to run them sequentially because they are all changing the same files. And so you have to run them one at a time. But when you're running linters that don't modify the files, you can run them all concurrently. So the fact that Pants understands a concept of linting, or the concept of formatting, or the concept of packaging, or the concept of testing, or the concept of compiling, obviously, or publishing, or there are many others around introspecting your build graph and things like that. Type checking. There are many of these verbs here, but the fact that Pants understands the semantics of those allows it to. It means you don't have to describe the semantics of those, basically. And so there is an interplay between the declarative side of a build file and the nouns, if you will, and the verbs and how they act on these nouns. That is, it is one of the things we try to streamline and try to make obvious. Like, you should just be able to do, pants test : which is the sort of shorthand for the non-shell expandable shorthand for everything under this directory, and the right thing should happen. It should figure out like which are the tests and run them, and apply again caching and concurrency appropriately. So I would say the descriptive part is still declarative, but as I mentioned, we are trying to move away from requiring much of that at all. So thanks to dependency inference, you don't need to provide dependency information in the build files. So now your build files are pretty tiny. So because the system infers the dependencies from looking at imports and various other tricks at runtime. So occasionally you may need to override that in a build file, but it's pretty rare. It even knows in some cases how to do. Sometimes you have dynamic dependencies, like Django is very big on this, loading things by their name at runtime. And so the dependency inference code can look at static strings that look like package names and infer a dependency if you configure it to do that. So there's a lot of that. So we're slowly moving away from needing much in the way of build files or declarative sort of build configuration at all. So today, a typical very commonly a build file today has one line in it, which just is the line Python code paren, which just says there is Python code in this directory, which, you could also know by seeing there's a bunch of files with .py at the end. So we're slowly moving away from requiring much of any config unless you need to tweak things, obviously.
Yeah.
Then you can do that.
Have sensible defaults and then only have to specify something when it's different than the normal.
And let's see, I've been playing with the Linux version, but I know somebody's been working on I'm sort of a defender of the Windows platform because it's, the vast majority of programmers out there, people out there have Windows machines. So anyway, I know that somebody's been working on a Windows native version, right?
That's correct. So it runs today on POSIX systems. So it runs on Mac OS and Linux, obviously.
And WSL.
And it runs on WSL. It does not run natively on Windows yet, but we are actively working on that because this is kind of it's a shame and it's a weakness right now that we don't support Windows natively. We have Windows users, again, using it on the Windows subsystem for Linux, but that's not ideal. And that's why we are working on Windows support. I think it just came from, there's a set of biases in Silicon Valley that do not apply outside of Silicon Valley. And I think we were a bit slow to recognize that. And I think that's unfortunate. There's a bit of, kind of nobody in Silicon Valley, or very few people, developers are developing on a Windows laptop or whatever, right? Like most people are running MacBooks. Some are running Linux. Everyone who's working on a MacBooks is deploying on Linux, so they all have to interact with Linux a ton. So those are the two, and it's convenient that they are both POSIX systems, and so they're a little more straightforward to support. So where we're at right now with Windows support is a giant piece that we haven't really talked about of technology that undergirds everything that is how Pants works is a thing called PEX, which is short for Python executable. And while, as we mentioned, Pants supports Go and Shell and Java and Scala and Kotlin, and we're working on or looking at there's beginnings of support for JavaScript. We'd like to support Rust, obviously, because we are written in Rust. There is someone is working on support for C++. And we already support native code compilation for Python through sort of setup tools and those mechanisms. So I forgot where I was going with this now.
Oh, you're talking about Windows support.
Oh, that's right, Windows support. So PEX is a big underlying piece of Pants. It's what allows us to sort of resolve Python code and package it into files and ship it around. And it's just sort of a big building block there. And so to get Pants to work, particularly for Python, so PEX is important both for users who are using Pants for their Python code, but also internally as part of Pants' implementation because it uses Python. So PEX now works on Windows. That is a huge milestone. There are a few of its unit tests that still don't pass on Windows, so we're not declaring it really ready yet. So there's, I think, out of many, many hundreds of tests, I think there are about 50 that don't pass yet. And so once PEX works on Windows, and there are people out there who are using PEX directly without Pants, because it is also a command line tool for building these PEX files, these Python executable files. Once we're confident that PEX works, then we will begin the work of making Pants itself run natively on Windows, which I expect, hopefully, it's not a trivial undertaking, but if PEX works, that makes me much more optimistic that Pants will, because PEX does so much of the heavy lifting and the code sort of system-specific work.
I would guess that a lot of the challenges are around the differences between POSIX and Windows. And God, what a horrible thing for our industry that Windows is not based on POSIX. That would make so many things so much easier.
So,
like symlinks, I'm sure that just dealing with symlinks is a massive.
Well, when you're not aware of at a very superficial level, you might think, well, the difference is in like backslashes versus forward slashes, or case sensitivity on the file system, or having drive letters in your path. It's none of that, right?
That's
Like that. Those are the easiest problems to solve. The hard problems to solve are things like file locking and symlinks and sort of the low level,
the things that aren't easily mappable.
level, exactly, where there's not just a difference in syntax but an impedance mismatch. Like that's where.
So could PEX be used as a like a distribution format for Python?
Oh yes, that is actually its original purpose. Was it is a format, a tool, and a format for deploying Python, a single file, executable file that contains all of your own Python code and also all of your transitive third-party requirements. So essentially, you don't then need to run pip or create a virtual env or anything like that. So this file standalone is executable, but what it doesn't include yet, this is a thing that we're working on separately, is an interpreter. So essentially, when you run it, the first thing it does is look for a compatible interpreter on the system. So it knows, for example, the code in me requires whatever Python 3.9 in order to run, and then it will look on the system on the path for a compatible interpreter. It will test that the interpreters it finds are compatible, and it will choose the first one it finds and then execute your code.
That was one of the problems I was running into with WSL is the newer versions of WSL start with, I think, Python 3.10. And so the 3.9 interpreter was not available by default. You had to install it.
Right. And so if your PEX wants 3.9, you're stuck. So one thing that PANTS and more significantly PEX do with respect to Python is that they keep you very honest. Without a tool like that, you just sort of type Python and something comes up. And if you have multiple interpreters on your system, you're not really sure which they are. And PEX is very strict about stuff like that. And so a frequent error that people have is like, I said I was compatible with, Python 3.7 and now I can't resolve. And the reason is that you have I forget which one it is. There's like some fairly commonly used third-party requirement on PyPI that declares itself incompatible with 3.7.1 and only 3.7.1 and compatible with everything else in the 3.7 series. And so if your code says I'm compatible with all of 3.7, then it is correctly failing, but it is incredibly frustrating, right? It is being very strict at you, but it sometimes is frustrating. But it is good in the end because it is eliminating a class, or it is forcing a class of errors on you at build time that otherwise might only manifest at runtime.
Are you familiar with the Beware project? And one of the things they've been trying to do is make easy Python distributions.
I'm not super familiar with it. No.
Okay. Because they and when I hear this, I'm thinking, oh well, that would be maybe a nice thing to go hand in hand with what they're trying to do.
One thing that I sort of alluded to a little earlier is we are now also working on the problem of. Sorry, before I get into that, I should mention that PEX, there's a standalone tool you can run, but PANTS is a very convenient way to build PEX files because it knows you can say, build me a binary with this file as its main, and PANTS will know how to find all of the dependencies, both internal and external, and bring them all together and put them in a PEX and so on. But the other interesting thing we're working on is a separate technology that will, among other things, take a PEX and add an interpreter to it and ship that. Cool. Now you don't even need an interpreter. This thing is called SCIE, spelled SCIE. It's still a work in progress, although we are soon hoping to actually distribute PANTS that way. PANTS itself currently relies on there being an interpreter on your system that can run the Python parts of it. And we pretty soon hope to switch to shipping PANTS as a Rust and Python binary that has its own internal interpreter as an implementation detail, so you can run PANTS on a system that has no interpreter.
I'm a big fan of not having standard dependencies,
Mhm.
like system dependencies beyond like libc and some of the normal ones. It always
Exactly.
it always is frustrating when I'm
Oh,
go to a new
very.
machine and try to get a tool chain up and running, and it's like, oh god, like there goes the rest of my day.
of course you
Like
have to install these things.
Ruby is just
Oh,
the freaking worst with this. It's like, every time I need to get the Ruby toolchain going, it's like, there goes my day.
right.
Many
Well,
many users have hit this problem. I think Bruce, even you encountered this at one point, right? Where it's just really frustrating that to run the tool has Python as an external dependency, and we are now moving towards bundling it, which will be great for many reasons, including that we will not need to support Pants itself running on multiple interpreter versions because it only needs to run on whatever it's being bundled with. Your code can be any interpreter version still. Like Pants today runs on 3.7, 3.8, 3.9, but your code can be 2.7 or 3.11 or anything. Because Pants' own interpreter is just its own implementation detail.
yeah,
For the DSL, for your build DSL.
yeah.
Yeah.
Well,
And for the rules.
Yeah.
certainly like hearing all these things. So when did you start Toolchain?
We started Toolchain in 2018.
Okay, and how many people do you have, and how are you funding?
So we are, including sort of contractors and so on, there's about 14 of us. So still pretty small, and mostly developers, but also now some developer relations and sales and marketing. And we are venture backed. So we've had some very, we're very grateful to have had
Some bootstrapping.
seed firms believe in us. So.
And you're all about pants. That's
what we're about really is. Sorry, I don't know why my phone decided to ring. What we're really about is developer productivity, right, and making developers happy and productive. And we, Pants is sort of the technology that we believe is really
best
suited for this in the real world for multiple reasons. One is Python. And its emphasis on, it supports many languages, but its Python support, we first launched it, Pants v2, with Python support only, because we had to start somewhere. And Python is now obviously so popular that we decided that was the gap in the market. That was where we felt like there was just not great tooling out there.
100% on that.
But then, what
world of Python tooling. So,
but what Toolchain adds on top of that is the remote caching, remote execution, which is where a lot of the performance comes from.
Yeah.
I find it interesting that you started in Scala and you started creating Pants for Scala, and then now seems like it's Python first and then adding the other languages afterwards.
Curious about that too. Your like journey to polyglot, to being a polyglot build tool, because most build tools are specific, or at least start specific to a language, and then some expand to multiple languages. But it sounds like V2 is when there was a major shift. I don't know. Tell me more about that.
That's absolutely right. So Pants V0, V1, they were Scala focused because we were working at a company that was using Scala, and that was the internal need. But when, Pants V2, as I mentioned, shares only a name with that earlier system. It was pretty much close to a blank canvas for us to, design what we wanted. And what we wanted was something that would be really useful to a wide variety of teams and be sort of very widely adopted. And rather than being
recognizing that most organizations have many different platform code,
even within a single project.
Yeah. But one thing 90-something% of them had in common was Python. Python underwent this sort of massive revolution, I'd say, in the last maybe 10 years or so, maybe a little more, where it went from being what I facetiously refer to as fancy bash, right? It was just like a slightly better scripting language, to a core language that people are building entire businesses out of, whether it's Django or Flask web apps, or Fast API now, or
Machine learning.
obviously machine learning and data science is the language of choice
Well, I think
for
that's
those
what
use
really
cases.
rocketed it into the stratosphere.
100%. So suddenly, if 10, 15 years ago, the truism was every company is a software company, I think it's fair to say now that every company is a data science company. And
Python is the language of data
Python
science.
is the language. And so
And it's the build tool of Python.
that's kind of where we were going with that. So of course, people have other languages. Certainly Scala has some really good uses in the data science area. And we want to support all those languages for multiple reasons. One is we just want you to have a single uniform, even if you're Python centric, but you also have code in these other languages, we want you to have a single uniform user experience. So pants test : will just run all the tests, whatever the language is. And you don't, it's a pretty common experience where you're mostly writing in Python, but occasionally you had to go tweak the Go code, and now you don't want to have to go and learn that tool chain. You just want to run the same command and the right thing happens. And if so we wanted that. We also think that some of the ideas that we first tried out on Python, such as dependency inference and using static analysis instead of manual configuration, are really valuable in any language. I think they really, in JVM, JVM is very, certainly Java itself, but really all of these languages are quite verbose when it comes to dependencies and imports, and having to sort of replicate all of that in build files is laborious and annoying, and people don't want that. And so another reason, so now we're seeing essentially Pants use is spread out from Python usage. It started with Python because that's all we supported. And then they were like, well, companies that had Python, but they also had some Scala and some Java or some Go. But now we're actually seeing more and more usage of repos that don't have Python in them, particularly starting to see it with Go, which is obviously very gratifying, but a little surprising, but it's great. And also with JVM, we're now seeing user bases that are like all Scala code bases, but using Pants because alternatives are much more laborious to use. And so I think obviously the big thing we need to support next is JavaScript. And the main reason that has not happened yet is the JavaScript ecosystem already has a giant wealth of tools, of build tools, very good ones.
Horrible in my opinion, but
oh, I don't know. I mean, what we don't want to do is that XKCD comic where, there are 14 competing standards. We should, build one to unify them all. And now there are 15 competing standards. So we don't want to do that. So we want to figure out what Pants can bring to that ecosystem that is additive and not, doesn't create even more fragmentation. And so the main reason it hasn't happened yet is that none of us are on the core team are experts at JavaScript, and we are really kind of looking for partners, design partners, to help us figure out what the most meaningful JavaScript solution. Meanwhile, what we do have is you can use Pants to run some underlying. So Pants can run sort of generic shell commands that you give it, and so it can run your,
you can
npm or whatever your yarn commands. We would like to have a somewhat tighter JavaScript integration than that.
Yeah, that makes sense. So one thing I'm curious about with Pants is I think build tools tend to kind of either fit well for smaller, more simple use cases, or fit well for more complex, larger use cases. So Bazel being, on the one end of the spectrum, and then things like, I don't know, Maven being on the other or whatever. And so do you see Pants as being able to, is it more segmented at one side of the spectrum, or really is it trying to be something that can cover the broad spectrum, or what do you think?
Well, it's definitely oriented towards the supporting you as you grow and get more complex. So using Pants does not require that you adopt a sort of monorepo architecture, but it is very strong support for that. So it is good at things that the conventional Python ecosystem is not necessarily strong at. So supporting things like having a single monorepo from which you deploy many different binaries that all have like intertwined dependencies, etc.
Can you just define monorepo for everybody?
Sure. So as your code base grows, you kind of have to make a decision about its architecture. And one way to do that is to keep splitting it up into, say, team-based repos or project-based repos, and then sharing code across those repos gets very difficult and has to be done typically through publishing and versioning, and it becomes, you fragment your code base, and
you
it
get a
seems
coordination problem.
exactly like you've chosen one side of that trade-off. Mono repos where you keep one unified repo where code depends on each other. There isn't really an internal versioning problem. You're not introducing, you have the external jar hell problem, but at least you're not introducing jar hell into your code because everything depends on each other at build time, at link time, if you will, at head. Essentially, the versioning is done through Git or your version control system. And so you end up with a large repo that has code from possibly multiple languages, supporting many different libraries and many different projects and many different binaries and many different services, and they all get deployed out of the same repo. And I personally am opinionated that I generally prefer mono repos for the simple reason being, and this is a very universal experience, when I make a change, I can see all the downstream impacts of my change because they are in that one repo. And if you have these poly repo, these many small repos, you have no way of knowing who is consuming your code. And because if they're consuming your code in a versioned way, you kid yourself that you don't have to worry about it because like they can worry about it when they upgrade. But what the hell kind of attitude is that in a team to say, I am just going to punt this problem onto my future coworkers, like somewhere down the line, like, yeah. So I like I very much prefer the idea of being responsible for the impact of your own changes all the way through to production, and a monorepo makes that much more tractable, but it requires tooling, and Pants is an example of that kind of tooling. So in answer to your question about complexity, I think Pants is there to support you as you go from simple to complex, which you will inevitably do. Yeah. So one of the reasons we wanted to make Pants easier to adopt was to make it easier to adopt sooner before you have the problem, make it beneficial to adopt sooner, because the sooner you adopt it, the sooner you can tackle the growing pains. If you punt on adopting Pants or a tool like it until you already have the growing pains, and then you realize that to solve those pains, you first need to have an adoption process and an onboarding process to some tool, and your code base is already kind of in a difficult state, and so that adoption becomes very hard. It's sort of, an ounce of prevention is worth a pound of cure. And so we wanted to span that transition from simple to complex because everybody goes through that transition, and observing, oh my God, my code base is like super complicated, and what tool can I adopt to simplify it? I mean, yeah, do that if you have to, but if the tool is simple enough and beneficial enough to adopt earlier down the curve, you can maybe not have those growing pains be quite as bad.
That's been my experience so far, is that even just a trivial repository is easy to set up and use with Pants. So
that's good to hear.
Yeah.
Because everything is, I speak from our ambitions here. Like this is software, so obviously it has flaws and it's not perfect yet. But that is, I think it is further along than most systems in this space in achieving that goal, and that is a very strongly declared goal. Of the earlier you adopt this, the better your life will be, and to back up that claim, we have to make it easy to adopt.
It's one of the meta challenges of our industry is that generally technology has some complexity cliff where you reach the limit of what it can do, and then you have to rewrite everything, rebuild, re-architect, choose a different tool that's more oriented. And I think Bazel is on the other side, where you can probably handle any amount of complexity, but it is not fun for an early adopter, beginner, small project. And so they kind of chose, the other side of the spectrum, but very hard to have a technology that can fit across the whole spectrum and takes a lot of intention and effort. So it sounds like you have that intention. And
I think so. I mean, one really big example is when you start out, you say in Python, you want to have all of your code use a single interpreter version and a single set of third-party dependencies, what we call a resolve or a lock file. And at some point, you may end up needing more than one of those. You may literally have different binaries or different use cases where the dependencies, they just really do need incompatible versions of those dependencies. And so now you have two separate universes of requirements. And so now you need a tool that can handle that. So Pants can handle that. Pants can model like multiple sets of dependencies and knows which code belongs to which universe of dependencies, etc. It is way better if you adopted Pants before you hit that point than trying to adopt it when you have already got that problem.
Unwind it, yeah.
So one of the things I know that you've been working on is build speed. Have you ever done comparisons between, like, say I set up a Java build using Gradle and you do the same thing using Pants? Have you done any experiments where you're racing? You don't have enough people.
No, we have not. Again, like a lot of the the Pants itself is open source. I should mention, obviously, Toolchain is a company, and our remote caching and remote execution services are proprietary. But Pants, the open source side of things, is a fully open source project with separate governance. And so we have many contributors and maintainers who do not work at Toolchain and are full participants. And I think we may not even be a majority anymore in our own open source project, which is fine.
That's great,
because we want everyone to feel empowered. And so if someone wants to go and do that
benchmarking,
that benchmarking, they're extremely welcome to do so. We have not done it. And it's a little hard to say what an apples to apples comparison would even be. Because, for example, does remote execution
you focus on
factor into this? Is like,
or incremental, how many cores do you have? What's your disk speed?
Right. Do you care more about the incremental case or the sort of clean build case? Do you care about remote caching? So for CI, for example, CI containers typically come up, with no state and no memory, and the CI provider's caching is very hard. It's very heavy weight. Like you can cache and restore an entire directory. Typically those directories grow without bound. You don't know how to construct a cache key correctly. Like you have to manually construct cache keys in config. So, there are so many nuances here that it's a little hard for me to necessarily see what an you have to first define the benchmarks, like any benchmark, right? Like with database benchmarks, you have to say what it is you're trying to do.
Yeah, that makes sense. Mm-hmm. What's the exciting future of Pants? What's on the horizon?
Well, we do want to get people more into remote caching and remote execution because it is so eye-opening once you do that and you see your CI times drop from like an hour to 5 minutes, especially with incremental builds, not having to repeat a lot of work. So that's kind of very exciting. I would say more language support, JavaScript, Rust is a big one that we want to support because we use Rust ourselves, so purely selfishly. And then another big thing that is coming very soon is support for what we're referring to as environments. So where you can essentially do things like cross build. So you can run on Mac or Windows, hopefully soon, but execute in Docker. So individual processes that are marked as being platform sensitive, platform specific, can run in Docker. So you can do things like run natively on your Mac OS laptop because you like it and it's user friendly, but you're actually building, testing, running even locally for Linux in a way that is which is the platform you presumably care about because it's the platform you're deploying to. And that sort of all happens very transparently and without you having to mess around with Docker containers, etc. And so that is an exciting thing that is coming up.
That's great.
What about Taylor? Because that will take, if I start with, a non-Pants based build and I run pants Tailor, it creates the build files for me. Is that just for Python, or will that work with other languages as well?
No, that's expected to work for every language. So we allowed ourselves one pants-related pun in the system, which was the name of this goal, Tailor, which creates the initial sort of an ongoing build that you build files for you. So again, build files don't contain dependency information, so they're usually pretty tiny. But even those tiny ones are generated when you run this pants Tailor command, and you can keep running it as you add new directories and so on, and it will like fill in the build files in those directories. We expect Tailor and dependency inference are core features, and we don't really consider a language to be supported until Tailor and dep inference work for them.
And so what does Tailor work with now? I mean, like Java, Kotlin? Oh, okay.
Yeah, I'm pretty sure. I wouldn't swear on a Bible that Kotlin is supported, but I'm pretty sure it is. Yeah.
Okay. Well, give it a try.
I haven't personally tested that out, but yeah, I think generally the idea is that Tailor needs to be. And I should mention, like, Pants has a very rich plugin API, and all of the built-in rules that it ships with are built using that API. So there's no like hidden secret internal only API that only the Pants core can access. So if you want to write your own plugins and rules and support for stuff, the Pants repo is full of examples.
Mm-hmm.
So and we obviously try to document as best we can. Documentation in open source is a whole topic to itself. We're doing our best with documentation.
Mm-hmm. Yeah, and I've noticed that the Slack channel is a very helpful way to, if you get stuck, you have problems or whatever.
It's good support in there.
Yeah, nice. It does, and there are no dumb questions.
You're treated kindly.
Yes.
Yeah. Our informal slogan there is there are no bad questions, only bad documentation. And so, or incomplete documentation. Yeah. So we really pride ourselves on the strength and welcoming nature of the community. It was very important. We know that this is complicated, and we know that there's a human tendency to assume that everyone else knows what you know, and if they don't get it immediately, then they must be dumb. But actually the opposite is true, and we want to make sure that it's a friendly place to ask questions and participate. We're trying to, as I said, this isn't a very often open source systems, and particularly build systems, are very sort of thrown over the wall and like, this is how it is. We made this for our internal use, and if you find it useful, great, but you are not welcome to contribute back. And we have the opposite here, where we very strongly encourage participation, contribution. Your contribution could just be a question or opening an issue or fixing a tiny bug or whatever it is. But we really do want that community engagement. It is a core strength of the system that community is available to you.
Do you have somebody who's dedicated to documentation, or is that just distributed among everybody?
We unfortunately do not yet. We write the documentation as we go. The feedback I've heard is that it is good for open source documentation. I would add that is not saying very much. So it's good.
That's what damning with faint praise.
Exactly. And part of it is that the plugin API is not completely stable yet, because as we learn about more use cases, it is a lot more stable than it was 6 months ago, but it is not fully stable. And so we still allow ourselves to change it without deprecation cycles. And so when you upgrade Pants, there's sometimes we provide guides on how to upgrade and how to change your plugins if you have any. So the documentation is really important, and evolving the documentation is really important, because when you have an API that's not really fixed in stone yet, you need to document how to use it and how to upgrade across it. No, we would love to put more professional writing into the documentation. It is a matter of time and resources.
Mm-hmm. Mm-hmm. And what is your business model? I mean, you said you have is it consulting and you have a software as a service kind of thing?
Yeah, so 3 big things that a toolchain on the commercial side does. One is the remote caching, remote execution, either as SaaS or we are about to launch on-prem, because many of the certainly larger organizations cannot use SaaS for this for regulatory and compliance and security reasons. The second thing is enterprise support. So there are companies out there who want to adopt, obviously, open source software, but need there to be support for it above and beyond the open source level support, which is best effort.
Have you gotten any pushback from somebody getting a PO at a large organization for a lot of money for pants, and just the name kind of triggering some red flags in an organization?
I mean, no, but I would love to be a fly on the wall in some of those conversations. And then the third thing we do offer is professional services, where sometimes a company will say, well, we have this internal custom language or this internal custom code generator, or we need support for this external language. Just would you could build it in a fraction of the time it would take us to build it. Can you build it? And then in some cases we will do that if it's if we think it's beneficial, particularly if we can open source. So if someone came along tomorrow and said, like, I would, can I pay you to add Haskell support? We would go and figure out how to do that. So those are, but obviously the main thing is the remote caching, remote execution services, because that is,
that's huge.
That just speeds up your build. Like that's what takes you from, that's where the promise gets fully delivered, where, okay, I put all this effort into adopting Pants. And it makes things faster because it has local caching and it can apply concurrency on the number of cores on your machine, and that's great. But to really get my CI times down by an order of magnitude, that's where remote caching, remote execution comes in, and that's kind of the big benefit of toolchain beyond open source Pants.
I have a theory that more compute time is wasted on repeated build execution that is totally unnecessary because somebody else has done the exact same thing than is spent on cryptocurrencies. Like the amount of waste in CI and developer machines just doing the same computations over and over again is identical. Like it's just is so silly.
I mean, every CI run overlaps with every with its predecessor by like so much. But the only way to tease that out and take advantage of it is a system that can break your build work down into many, many tiny, fine-grained work units, and that's exactly what Pants does. And that's where earlier systems cannot. Basically, their model of your code, like you said, is at the class path level, and they can't really do it in a fine-grained way. But if we can take your build and break it down into many thousands of pieces, and each of those pieces can separately be considered for caching and for concurrent execution, that's where, so because you're absolutely right, like most builds are doing the same work over and over and over again, and we all understand this intuitively.
Based on downloading the same things over and over and over again. It's just as silly.
And we all intuitively know this. Like when we look at builds, we sort of intuitively know that. Like I know that my change only affected like a handful of tests, but yet every single one of the thousands of tests had to run. So yeah.
Good. I'm glad that you're solving that problem. The waste is
enormous,
and just why? It's unnecessary.
Because that's not the problem we're trying to solve. We're trying to get our product out, and the build system is just in the way.
That's right. So Pants, it's not in your way.
Yeah. The name, with hindsight, I don't know, maybe we missed an opportunity to change the name when we launched V2, but it is what it is at this point.
It's fun.
I don't know. A little bit of mirth is fine.
Yeah. Got to keep it human.
And it is kind of fits with the Python world. So
silliness.
Yeah, a little bit of silliness.
Yeah. Well, I'm excited to try Pants. I will give it a try and report back.
Great.
And I think it sounds like you all have the right heart behind it and doing some really good stuff. So thanks for all your work and making the developer world more productive and better.
Yeah. It's honestly, I'm glad people enjoy it, but I love working on it so much that I would be working on it even if I was the only user.
That's great to hear. That's huge.
Thanks, Benjy.
Thank you.